Welcome to the Math Record. This would be the first video in Chapter 4, Applications of Integrals. Today I'll be covering displacement, total distance, and position. So first off, what is the difference between displacement, and total distance? Well, the difference is pretty simple. Displacement only cares about position, and total distance cares about the process. So let's explain this with a picture. Let's say we have a point here, that's our initial point, and a point here, this is our final point. And let's say we walk just on a straight line from the initial point to the final point. Our displacement is the position, cares about position, so this is the final point minus the initial point, so this is our displacement. Now what about total distance? Well, our total distance cares about the process, so our process is just that straight line, so it's just this length. So that means our displacement in this case is the same as our total distance. Now if we had a distance that goes halfway and then walks back halfway, and then we go back this way to the entire length, then our displacement doesn't change because it only cares about position. Final position minus initial position. This is still our displacement. Now, total distance cares about the process. So we went halfway to the right, halfway to the left, and full way to the right. So half plus full means that we went twice the displacement, because half plus half is full, plus this full means twice of the full. So that means the total distance in this case would be twice the amount of our displacement. And that's the difference between displacement and total distance. So how do we calculate displacement and total distance? Well, let's look back at the fundamental theorem of calculus. So a to b, our derivative in respect to x, is equal to our original equation at b minus original equation at a. So let's understand this with a basic example. So this would be our original equation. This would be our derivative. Now let's use a parabola. So the derivative of parabola is linear. Now if we take an area, let's say this is A, and this is B, and this is A, and this is B, the area of our derivative, which is under this curve, this area, based on the fundamental theorem of calculus, states it's just equal to, here, this point is f of b, minus this point, which is f of a. And as you see here, it's just this value. So this area is the same thing as this. And this is just our displacement. That means our integral just calculates for our displacement. And it's just that simple. Well, how do we calculate for total area? Well, if you think about it, this point only goes from here to here, only in the positive direction. So that means our displacement in this case is also our total area. So when is the case where our displacement is not our total area? Well, that would be if, let's delete this graph, because this only has been dealing with positive area. Now let's say we have this entire linear graph, and we have a negative area. So that's a negative area because it's below the x-axis. Now if it's above the x-axis, let's say we have this area. This area is positive because it's above the x-axis. Then our displacement will only care about the position. So we started at some point, we have negative area. That means we're going back in the curve. So in a way, it's like going back here. And then we have a part of the curve, positive, and this area would cancel out to make 0. So from here, let's say the point stops here and then goes back to this point. Now from there, we have the rest of this area, and this area will be to here. And that means this area will calculate for our displacement. So that will be the idea of our integral, or final minus their initial. So that is just our integral by itself. Now we're taking an idea of the total distance as we labeled. This section calculates for this. This section calculates for this distance. And this final area calculates for this distance. So we cannot take this distance and take it away from here because for total distance, we only care about the process. We care about the process. So that means we had to not make this negative, we had to make this positive. So to fix our integral, what this means is that we had to make any negative to positive, which is pretty simple. We just stick an absolute value in there, and that's it. So to find our displacement, we have our integral. To find our total area, total distance, we're going to plug in an absolute value. To do this, let's try an example. So let's say we have a car that's moving at a rate of x cubed. And let's say its initial position, x naught, is at 2. So the question is, what is its displacement and total distance? I'm just write TD for total distance from x equals 1, from let's say x equals -1 to x is equal to 2. And then I'm going to ask for where the final position is at. Okay, so let's calculate for displacement first. That's just the integral from -1 to 2. And our derivative, x cubed, because that's our rate, as I said before, in respect to x. Now, the integral of this is x to the power 4. The derivative of x to the power 4 is 4x cubed. We want x cubed, not 4x cubed, so we scale this by 1/4. And we evaluate it from -1 to 2. Plugging that in, 2 to the power 4 is 16, divided by 4. Plugging in -1 to the power 4 is 1, so minus 1 over 4. So that means 15 minus 1 is 15. 16 minus 1, 16 minus 1 equals 15, divided by 4. So that means this is 3.75 as our displacement. Now our total distance, as I said before, we just stick an absolute value. So usually when we have, this is a simple example, but when we have more complicated ones, you're usually just going to plug this in your calculator. But this is a simple example, so let's kind of see how to do this. So the graph of a cubic looks something like this, and the negative values are just from here, and the positive values are here. So we could split this graph up from -infinity to 0 to 0 to infinity. So basically, we can rewrite this as the integral. So the negative ones are -1, and it goes to 0, as I said before. And then x cubed dx plus, and our positive version goes from the positive values 0 to 2, and that's still x cubed. Okay, so the derivative of this, the integral of this, as I said before, was right here, 1/4 x to the power 4. Now, if we plug in 0, that is 0. Plug in -1, that's 1/4. So we minus 1/4, so that's a -1/4 area. As we said before, we want to make this positive, so we're going to turn this to a positive 1/4. So this would be just a positive 1/4. Now for this area, plug in 2 into our integral, so that's 16 over 4. Plug in 0, that's just 0. So we have 1 over 4 plus 16 over 4. That means our total distance is 17 over 4, which is 4.25. Okay, now to calculate our position, our final position, because we already know our initial position, our final position, as we said before, displacement calculates for position, which is displacement, I'll just write displacement, is equal to initial position plus our displacement is equal to our final position. So our initial position is 2, our displacement is 3.75. That means our final position is 5.75. And that's basically it. Well, thanks for watching, and in the next video, I'll be covering area.